In 2023, researchers at the University of Michigan recorded something that shouldn't exist: a surge of conscious brain activity in two patients whose hearts had already stopped beating. Dr. Borjigin and her team observed gamma wave activity, the fastest brain waves associated with consciousness erupting in the dying brain's hot zone, the junction between temporal, parietal, and occipital lobes. For those final moments, as life support was withdrawn and death crept forward, these patients' brains became more alive than they had been in years. They couldn't tell us what they experienced because they didn't survive, but the recordings revealed something profoundly unsettling. The brain doesn't simply shut down when we die. It ignites. This discovery echoes thousands of testimonies from those who did return. Research from the Near-Death Experience Research Foundation analyzed over 1,100 cases, finding that 835 people reported an increase in alertness and consciousness during their near-death experiences. Not a decline, but an expansion. Dr. Bruce Greyson, a psychiatrist at the University of Virginia, has studied over 1,000 near-death experiences throughout his career, documenting cases where people report vivid, coherent experiences during cardiac arrest, when brain function should be impossible. They describe floating above operating tables, traveling through tunnels of light, encountering deceased relatives, and experiencing a clarity of mind that surpasses normal waking consciousness. But here's what makes scientists pause. Approximately 10 to 20 seconds following cardiac arrest, brain cortical electrical activity essentially flatlines. No measurable activity, no consciousness. Yet people return with memories so vivid, so structured, so impossibly detailed, they transform lives forever. In a landmark 2023 study led by Dr. Sam Parnia, researchers monitored 567 cardiac arrest patients across multiple hospitals. About 40% showed brain activity consistent with consciousness re-emerging during CPR, sometimes up to 60 minutes into resuscitation. Of the survivors interviewed, nearly 40% reported awareness during the event, and 20% experienced what they described as recalled experiences of death itself. These aren't hallucinations born from oxygen-starved neurons misfiring in desperation. The experiences follow consistent patterns across cultures, ages, and circumstances. Young children under 5 years old who have absorbed minimal cultural conditioning about death report near-death experiences with the same core elements as adults. This presents neuroscience with an impossible paradox. The central tenet of neuroscience holds that all human experience arises from the brain. Consciousness is what the brain does. When the brain stops, consciousness should vanish like a television switching off. But that's not what the evidence shows. Something persists when it shouldn't. Something experiences when experience should be impossible. And that leaves us confronting a question that tears at the foundation of everything we thought we knew. What if consciousness isn't trapped inside your skull at all? Why does red look like red? Why does pain hurt? These aren't easy questions. They're the hardest questions in science. And in 1994, philosopher David Chalmers stood before a conference in Tucson, Arizona, and proved that no one had an answer. He called it the hard problem of consciousness, not the problem of how the brain processes information or how neurons create behavior. Those, he said, are the easy problems. The hard problem cuts deeper. Even after explaining all cognitive and behavioral functions, one question persists. Why is the performance of these functions accompanied by experience? Why doesn't all this biological machinery operate in darkness without any inner light of awareness? Chalmers proposed something radical. Consciousness should be taken as fundamental, like mass or space-time, something that cannot be reduced to anything simpler. Physics doesn't try to explain mass in terms of something more basic. It accepts mass as a fundamental property and builds theories around it. Perhaps consciousness demands the same treatment. But if consciousness is fundamental, where does it reside? Only in human brains? In all animals? Where does the boundary lie? Enter Philip Goff, professor of philosophy at Durham University, who advocates for what he calls the third way, a version of panpsychism that proposes consciousness as a fundamental, ubiquitous feature of the physical world. The basic commitment, Goff explains, is that the fundamental constituents of reality, perhaps electrons and quarks, have incredibly simple forms of experience. Not thought, not intelligence, just raw, primitive experience at the most basic level of existence. For its proponents, panpsychism offers an attractive middle way between the extravagant belief in the soul on one hand and the reductionist there's only brain chemistry view on the other. As organisms become simpler, perhaps the light of consciousness never switches off entirely, but rather fades as organic complexity reduces through flies, insects, plants, amoeba, and bacteria. For the panpsychist, this fading continuum extends into inorganic matter, with fundamental physical entities possessing extremely rudimentary forms of consciousness that reflect their extremely simple nature. An electron doesn't think or feel pain, but perhaps it has some barely there flicker of subjective experience, something it's like to be that particle, however minimal. This isn't New Age mysticism. Leading thinkers of the Enlightenment, such as Gottfried Wilhelm Leibniz and Baruch Spinoza, were panpsychists, and the view had something of a heyday in the 19th century. In the last 10 to 15 years, there has been a new wave of interest in panpsychism in academic philosophy, and even to some extent in neuroscience. Contemporary philosophers like David Chalmers and Philip Goff describe panpsychism as an alternative to both materialism and dualism. It avoids the dualist problem of explaining how mind and matter interact across an unbridgeable divide, while also escaping materialism's inability to explain how subjective experience emerges from dead matter. But here's what makes your spine tingle. If consciousness pervades reality at its most fundamental level, what happens when your particular configuration of conscious particles dissolves at death? Do those elementary sparks of experience simply redistribute? And if so, what does that mean for you?
What if your thoughts aren't happening in your brain at all, but in the fabric of space-time itself? In the 1990s, Nobel Prize-winning physicist Sir Roger Penrose and anesthesiologist Stuart Hameroff proposed something that made mainstream neuroscience recoil: the orchestrated objective reduction theory, known as ORC-OR. The theory suggests that quantum superposition and quantum computation occur in microtubules, cylindrical protein lattices of the cell's cytoskeleton within the brain's neurons. Not in the firing of neurons across synapses, where science had always placed consciousness, but at a level 14 orders of magnitude deeper, in the quantum vibrations of proteins smaller than the wavelength of light. Penrose was suggesting a quantum mechanism for consciousness connected to the fine-scale structure of the universe, requiring a quantum computer in the brain able to modulate neuronal functions. Microtubules, Hameroff realized, fit the bill perfectly. These quantum processes regulate neuronal activity, building up like tension in a system until they reach a critical threshold. Then, in an instant, the quantum state collapses, and that moment of collapse is what we experience as a conscious thought. Your thoughts, in this framework, aren't merely chemical reactions. They're quantum events connected to the deepest structure of reality itself. The theory faced brutal skepticism. Quantum effects require near absolute zero temperatures to avoid thermal decoherence. The brain operates at 98 degrees Fahrenheit, far too hot, critics said, for quantum processes to survive. But then evidence emerged that shouldn't exist. Research discovered quantum vibrations in microtubules inside brain neurons at ambient temperatures, corroborating the theory. Studies found functional quantum behavior in photosynthesis proteins operating in direct sunlight and coherent vibrations in microtubules spanning terahertz, gigahertz, megahertz, kilohertz, and hertz frequencies, a multi-scale hierarchy. Nature, it seemed, had mastered quantum computing long before humans conceived of it. But here's where reality fractures. Hameroff proposed that microtubule condensates in one neuron can link with microtubule condensates in other neurons and glial cells via gap junctions of electrical synapses, with quantum objects tunneling across the gap, extending across a large area of the brain. If consciousness operates through quantum entanglement, where particles remain instantaneously connected across any distance, then the boundaries we assume between individual minds might be illusory. Some theorists propose that quantum coherence in microtubules might allow for non-local interactions that extend beyond the brain itself, potentially linking individuals or even all living beings in a vast interconnected network of consciousness. A 2025 study using twin pairs and quantum circuits found that entanglement of qubits explained 13.5% of variance in cognitive accuracy, with quantum entanglement showing up to 31.6% increase in variance across responses. The researchers concluded that quantum entanglement enhances conscious experience and facilitates faster, more efficient learning, pointing to anomalous cognitive mechanisms capable of anticipating future, unpredictable stimuli. Your consciousness might not end at your skull. It might extend through quantum connections into a reality we can barely comprehend. And if consciousness is fundamentally non-local, what happens to it when your body dies?
Just weeks ago, materials scientist Dr. Maria Ström at Uppsala University published a theory so radical it flips physics on its head. Consciousness isn't produced by the brain. Consciousness is the fundamental field from which space, time, matter, and your brain itself emerge. The theory proposes that universal consciousness operated as a fundamental field that existed before the Big Bang, seeded the formation of space-time, and continues to shape the emergence of individual awareness today. Think of reality not as dead matter that somehow generates consciousness, but as an infinite ocean of awareness from which everything we perceive, galaxies, atoms, thoughts, ripples into temporary existence. The framework integrates three principles: universal mind as the fundamental source of potential, universal consciousness as the capacity for awareness, and universal thought as the creative mechanism that shapes formless potential into tangible reality. Before the Big Bang, the consciousness field existed in a perfectly symmetrical, undifferentiated state. Your individual mind, in this view, isn't something separate from the universe. It's a structured pattern within the universal field, a temporary wave on an eternal ocean. Physicist John Wheeler, who coined the terms black hole and wormhole, spent the final decades of his life obsessed with one question: are life and mind irrelevant to the universe's structure, or are they central to it? His answer came in the phrase, "it from bit," proposing that every particle, every field of force, even space-time itself, derives its very existence from information, from questions asked and answers received. Wheeler stated that information is the most fundamental building block of reality, and that the universe should be seen as a self-synthesized information system developing through a closed-loop cycle. He suggested that we are participants in bringing into being not only the near and here, but the far away and long ago. If the universe is fundamentally information, what does that mean for death? Quantum field theory suggests that consciousness isn't locked inside your skull. It's a living field of intelligence that recycles everything: energy, matter, and you. Consciousness becomes a fundamental property of the universe, like information, energy, matter, and space-time. Irreducible quantum information distributed in a cosmic way, connecting everything that exists. The Global Consciousness Project has reported statistically significant correlations between random number generator outputs and emotionally charged collective events, natural disasters, global meditations, tragedies, suggesting consciousness operates non-locally, coupling across individuals in ways classical physics cannot explain. Your thoughts might not be confined to your skull. They might extend through information fields that connect all conscious beings. In Ström's model, when the body and brain stop, the structured pattern loses its organization while the underlying field stays in place. The familiar sense of self can come to an end, while awareness as such continues as part of the universal background it always belonged to. The wave collapses back into the ocean, but the ocean, that fundamental field of consciousness woven into reality's deepest fabric, never empties. It was here before the Big Bang. It will be here after the last star dies. And according to these theories, you were never separate from it at all.
You're going to die. That's the only certainty. But what happens in that final moment? When your heart stops, when the gamma waves surge one last time, when the quantum entanglements that might define you begin to dissolve? After documenting dying brains, consciousness fields, and quantum theories that challenge everything we thought we knew, science stands at the precipice with something profound to offer. Not answers, but better questions. And the limitations are as revealing as the discoveries themselves. What's critically lacking is a correlation with experiential content, which is important to verify because it's possible that these neurophysiologic surges are not connected to conscious experience at all. The gamma spikes could stem from pain, spasms, or even phantom electrical noise from the muscles themselves. This is the razor's edge where science stands today. We can measure the dying brain's final electrical storm, document thousands of near-death testimonies, propose radical theories about quantum consciousness and universal fields, but we cannot prove that any of it means consciousness survives death. We can only prove that the question refuses to die. Dr. Sam Parnia, whose cardiac arrest research has documented awareness in clinically dead patients, states plainly, there is no science that shows us how brain cells can generate thoughts. A single brain cell produces proteins. How can that suddenly lead to this incredible phenomenon of thought and awareness? That's called the problem of consciousness. There is no science to address it. He suggests the brain may be an important conduit, but consciousness itself, who you are, might be a separate entity that interacts with your brain, like a computer accessing the internet without producing it. Without the computer, you cannot access the internet. If you damage the computer, you don't see signs of the internet, but that doesn't mean the computer is producing it. To date, no scientific study has found reliable evidence of an afterlife. Consciousness, potentially non-material, resists the traditional framework of measurable phenomena. Near-death experiences have offered glimpses into altered states of awareness, yet they remain anecdotal and fall short of proving an afterlife. Despite fascinating stories of consciousness beyond the brain, near-death experiences have little validity from a strictly scientific perspective because the evidence is purely anecdotal. But here's what the scientific community increasingly acknowledges. As Dr. Bruce Greyson notes, the question of consciousness and its relationship with the brain remains one of the biggest mysteries in science. Yet the evidence keeps accumulating in ways that defy easy dismissal. The AWARE study revealed that 40% of cardiac arrest survivors were aware during the time they were clinically dead, and one patient had a verified out-of-body experience. Dr. Parnia stated, "The evidence thus far suggests that in the first few minutes after death, consciousness is not annihilated. Not proof of an afterlife, but proof that consciousness behaves in ways our current models cannot explain. All evidence points to memories being stored in the brain, and conscious experiences happening in living, functioning brains. Diminishing brain activity through injury or anesthesia causes loss of consciousness, and brain injuries can erase whole categories of experience. The materialist case seems airtight, and yet the paradoxes persist. The gamma surges in dying brains, the coherent experiences during flatlined EEGs, the quantum theories suggesting consciousness operates beyond classical physics, the mathematical frameworks proposing consciousness as fundamental rather than emergent. Dr. Borjigin, who discovered those final gamma surges, offers a stark assessment. Death is the disease everybody is going to get, yet we don't know much about it. Perhaps that's the most honest answer we have. We stand at the edge of the greatest mystery humanity has ever faced, armed with more questions than answers, more theories than proof, more wonder than certainty. The brain may be a receiver rather than a generator. Consciousness may be fundamental to the universe.
individual awareness may dissolve back into a cosmic field that never began and will never end. Or perhaps when the brain stops, everything simply goes dark forever. The only certainty is this: one day you'll find out. And until that moment arrives, the question remains, haunting, inescapable, and profoundly unsettling. What happens after death? Science has learned to ask better questions, but the answer still lies beyond the veil, waiting in that undiscovered country where every single one of us will one day travel, whether we're ready or not. If this journey into the deepest mystery of existence left you with more questions than answers, you're not alone. We explore the unknown every week here on Dark Dimensions X, from the edges of consciousness to the darkest corners of reality. Subscribe and join us as we continue questioning everything we thought we knew. What do you think happens after death? Share your thoughts in the comments below. Until next time, stay curious, stay questioning, and remember, the mystery is far from over.